Hi guys, this is Sabhi from Engineering Master. Welcome to another episode of Engineering Master. Everyone is using electricity in our daily life. This video will improve the understanding of electricity, how does it works and how does it produced. We will try to cover all the basic terms in electricity. Let's go to the video. In order to understand the electricity, we have to start with an atom. If we look at how electricity works or where does this electricity came from, we have to start with an atom. We know every object in the world is made of atom. If you look at the structure of an atom, it has a protons. Protons is a positively charged particle. Then along with proton, it has neutrons. These protons and neutrons are enclosed in a nucleus. Around the nucleus, electrons are circulating in an orbit or shells. Negatively charged electrons are circulating around the nucleus. In normal atom, the number of protons and number of electrons will be same. That's why the atom is electrically neutral. As we see, the electrons are circulating around the nucleus in a shell or orbits. So maximum number of electrons which can be accommodated in the shell is given by a formula 2n square. That is first shell 2 electrons, second shell 8 electrons, third shell 18 electrons, like that. 2n square. N is the number of shell or orbits. So as we know, the outermost shell or valence shell or the shell which is far from the nucleus, which is very loosely bound to the nucleus, because the distance is more, that charge attraction will be less. If the electrons is tightly bound to the nucleus, this material is called insulators. If the electrons which is very loosely bound to the nucleus, this material is called conductors. In the insulator this is tightly bound, in conductors which will be loosely bound. So in the case of conductors, the outermost shell electron or the valence electron will be loosely bound to the nucleus. That means it is easy to eject the electrons from the atom. In the normal scenarios, because of some temperature variation or some external force, there will be a movement of electrons in the conductors. But it will be in random direction. We don't have any use of it. It is not producing any usable electricity. If we apply a voltage or potential difference, what will happen? The electrons will move in a specific direction, causing a usable electric current. If you look at the circuit, we connect a battery or power source to the circuit. What is happening? Electrons are moving in a specified direction from negative terminal to positive terminal. From this, we will get a new term, voltage. What is voltage? Voltage is the pushing pressure or force that pushes free electrons and causes current. We saw that if we apply a voltage, this voltage will push the free electrons in a specific direction. This is causing a current. The unit of voltage is volt. The term came from the great scientist Alexander Volta. The voltage is the difference in electrical potential energy per unit charge between 2 points. We know in dams or reservoirs, the water is flowing from high level to low level because of potential energy difference. Like this, voltage is the difference of electric potential energy per unit charge between 2 points. The next term we got is current. An electric current is the flow of charged particles such as electrons or ions moving through an electrical conductor. We have seen the current. Current is the flow of electrons through a conductor. The unit of electric current is ampere. What is ampere? If 1 coulomb of charge is passing through a specific point in 1 second, we can say 1 ampere current is passing through that. 1 ampere equal to 1 coulomb per second. What is coulomb? Coulomb is a charge of 6.24 into 10 to the power of 18 electrons. 6.24 into 10 to the power of 18 electrons is passing through a point in 1 second. Then 1 ampere of current is passing through that. So there are two types of current in electrical engineering. First one is direct current. Second one is alternating current. What is direct current? Direct current is a unidirectional current. It's like the current coming from the battery. The another one is alternating current, AC current, which we are using in our home. In alternating current, the direction of flow of electron switches back and forth at regular intervals or cycles. In AC or alternating current, electrons are not really moving from one place to another place. It is moving to and fro, or it is oscillating in its position. What is the reason for this to and fro motion of electrons in AC or alternating current? The reason lies on its production. If you look at an AC generator working, generator has two parts. One is stator, which is stationary part. Another one is rotor, which is rotating part. So stator is a permanent magnet or electromagnet which is producing a continuous magnetic lines. Rotor is a coil which is rotating in this magnetic field. So in AC, this is zero position, right? In this position, the coil will be parallel to the magnetic field. There will not be any change of flux in this position. From this position, it is increasing its magnitude. If the coil is perpendicular to the magnetic field, then the EMF will be maximum, or induced EMF will be maximum. Again, reverse this direction, coming back parallel to the magnetic field, then increasing in another direction. Again it is coming to the peak and going back to zero. This is called one cycle. Because of this nature of AC, these electrons are not really moving from one place to another place. This just moving to and fro from its position. Generator working principle is Faraday's laws of electromagnetic induction. We have covered this subject in detail in another video. I will provide the link in description box. Please watch that also. Another term is resistance. Resistance is the measure of opposition to current flow in an electrical circuit. Resistance is measured in ohms. It is symbolized by the Greek letter omega. Basically, the resistance is the opposition to the current flow. Resistance is used to limit the current flow in a circuit. Let's look at a circuit. In this circuit, battery is connected to a light and light is glowing. The current is flowing normally. If we insert a resistance or resistor in the circuit, what will happen? The flow of current is reduced and the light will be dimmer. In case of small LED lights, so if we are connecting this light without resistance, what happens? The excessive current will flow and the light will blow. In order to avoid that, we will connect the LED light through a resistor. So the resistor will limit the current flow in a circuit. The another important term is transformer. What is transformer? Transformer is an electrical device that takes given input voltage and changes into different output voltage without changing any frequency. The major role of a transformer is either to step up or step down the voltage depending on the situation where it is installed. Basically, transformer is increased to increase or decrease the voltage without changing the frequency. The working principle of a transformer is Faraday's laws of electromagnetic induction or mutual induction. There are three parts in a transformer: primary coil, secondary coil and a magnetic core. Primary coil, the input supply is given or the supply from the generator is given. Secondary coil is the output side. Transformer will work only in AC voltage. If we apply an AC voltage, it will produce a magnetic flux. The magnitude and direction of this magnetic flux will change in every cycles or every half cycles. So because of this change in magnetic flux in the secondary coil, an EMF will induced in it. So this is the basic working principle of a transformer. Transformer is a big subject. We are doing a separate series for the transformer. I'll provide the link in description box. Please watch that also. Another one is capacitor. Capacitor is a device that stores electrical energy by accumulating electric charges on two closely spaced surfaces that are insulated from each other. Basically, the capacitor is an electric charge storage device. Capacitor has two plates. Between that, electrical charge is stored. Let's look at the circuit. In normal scenarios, when a supply is applied and a capacitor is connected, the capacitor is getting charged and light is also glowing. If the supply is disconnected, what is happening? The capacitor starts to discharge. For a small time period, the light will glow. After that, it will be completely discharged. That's it, guys. I think you got a fair idea about electricity and how does it work. If you like the video, please like, share and subscribe. We'll meet in the next video. Bye.